All right, here we go. Whew. All right, so we have, we're trying to see if this is similar. We have 3 different rules. Angle, angle, angle. I don't have any angles it doesn't look like, right? But I actually do. We have side, side, side. I only get 2 sides and 2 sides. So I'd have to have this 3rd side somehow. But then there's the side angle side. And if we remember back to chapter 1, what are these angles called? Vertical. They're vertical, right? Anytime you have angles across from another angle, they're vertical. And that means that they're congruent. Okay? So, we know right away that angle FEG is congruent to angle QR or QER. Now, I kind of want to go in the same direction. So let's think about this direction that we want to go in. So one thing I noticed is this is little and this is big, right? But this is little and this is big, right? So we kind of have to go with that. So if we were to call this side 1, right? And this is side 2, right? We could do that, side 1 and side 2, right? And so S1, S2, okay? And this is the smaller triangle, right? So I actually call it the small triangle, and this is the large triangle. So, but which one would be proportionate to it? And if we're going to go small, big, then we have to go small, big. Does that make sense? Right? So that means that the side 1 of the large triangle would be this side. Okay? L1 would be this side. L2 would be this side. Because this is smaller, this is bigger. Does that make sense? Okay? And so, in doing so, if I go FEG, right, then I have to go REQ. Does that make sense? Because I have to go in the same kind of direction that we're going to go with our proof, which is to prove that the triangle FEG is similar to the triangle REQ. Okay? That's a lot just to start off with, right? So, RE small side, FE small side. Okay? Then the angle. So what are we looking for? We want to know that they are congruent due to SAS, right? Side, angle, side. Does that make sense? Okay? Because these angles are congruent, these sides are proportionate, these sides are proportionate. That means at some point, some number, right, multiplies this side to get to that number. Okay? So let's think about that. Some number x, so 3 times x is equal to 9. And that's definition of ratio. Okay? So there's a ratio that I can multiply this leg to get this leg. I'll be with you just when I'm recording. So, okay. Alright. Now, the top one, what was the reasoning behind that? You remember? What do we call them? What are these angles? I just said it. Not perpendicular. What? Come on, V. people. It's on your first test.
It's been a while since the first test.
I got 2 people sleeping or
Perpendicular?
not paying attention. Come on. Which one?
Perpendicular.
Not perpendicular.
Vertical?
Vertical. There we go. Thank you. It hasn't been a while since I actually said it on the film. I mean, come on. I said it like 5 minutes ago. Vertical.
It's all your fault.
Right? So, vertical angles. Okay? Definition of vertical angles. Okay? Now, definition of the ratios tell me that some number times 3 is going to be 9. What do you think that number is going to be? 3, yeah. How do you find that? Do division property of equality, and I get x is equal to 3. That means my ratio is 3. So, if that's true, then 3 times 5 should give me 15. Is that true? Is 3 times 5 15?
Yes.
Yes. Okay? So, that is, again, definition of a ratio. So we're using that ratio to prove that 3 times 3 is 9 and 3 times 5 is 15. So we know that those two sides are proportionate, right? So side 1 is proportionate to the side 1 of the big angle, of the big triangle, large triangle. Side 2 of the small triangle is proportionate to side 2 of the large triangle. And the angle of the small is equal to the angle of the large. Therefore, this is true. Okay? So, and then they asked, I'm sorry. They actually put EFG. That's my bad. So they wrote it as triangle EFG is similar to what triangle? So how would we write that? EFG. So they're going this direction, right?
QER.
So is this the small side?
Oh.
EQR.
So then we'll go to the small side, right?
ERQ.
So ERQ, right? So it's going small to big, small to big, right? So ER. So that will be your actual answer. ERQ. And the other answer is SAS. Does that make sense? A little bit? Questions? Any questions? Okay, questions. What are you lost on? Ask the questions. Because the only way you're going to answer it, remember, we talked about this. The only way I'm going to have success with you on the YouTube is to ask the same questions that you're asking on the YouTube. Right? So now you just watched this YouTube. You just watched me do this. You don't understand a damn thing. What is it that you don't understand and why?
How you got that set up?
How you got what set up?
The line and the side.
So like, how did I choose side 1, side 2?
Yeah.
Okay, so side 1 I chose because it was smaller than side 2.
Does it matter if you flip it?
If I put 3 over here and 5 over here,
No, if we made the 5 side 1 and then 3 side 2.
no. What does matter, if I make this side 1 and this side 2, then that would mean that this would be side 1 and this would be side 2. Those would flip. Good questions. Anything else? You sure? Come on, I know you're going to be watching this. Yeah, I actually do have like 5 more questions. That was a great question.
Can I ask a question?
Yeah.
Where would you use this in
Oh.
life?
In life,
Yeah, what would you use this for?
oh, I would use this in lots of places. Building, doing walls, building rooms, adjacent to other rooms, building a garden, trying to landscape, building a building, trying to make one building similar to another, or similar shapes are done mostly when we're trying to actually look at the height of something. That's what we do a ton of. So, like if they're looking at this building and they're trying to find the height, right? Then they're going to use similar triangles. They're going to use a height of something, say a person. I know that his height is so much, and I know this angle, it's called a sextant, and they use this actually a lot in when we did shipping in the past. I mean, they had to have these sextants to see the height of the sun off the horizon, right? But with this, it's saying there's two different angles here. There's this triangle, right? And then there's this triangle, right? And they are similar because the proportion from here to here should be proportionate from here to here. And from here to here should be proportionate from here to here. And these angles are the same, so therefore SAS. So we know that they're similar triangles to the SAS. Now we want to talk about, and the other reason we know is this is a right angle, right? So they're both right angles. Both triangles have this as an angle. That means this angle has to be the same. So even if we didn't know that these sides are congruent, we know that all the angles are congruent. Therefore, due to AAA, we know that these two triangles are congruent, or not congruent, are similar. And then we know that they're proportionate. So if I know the distance from here to here, and I can figure out the ratio, right, of proportionality, then I know the difference from here to the top of the building. But I also know, if I know that he's 6 foot tall, and I find out that ratio, then I'll know the height of the building.
Wait, yeah.
So-
Why are we multiplying 5 and 3?
What's up?
Why are you multiplying 5 and 3?
5 and 3. Oh, okay, so the 3 we were using is a little confusing because the 3 that we were actually using was this 3, the proportion. Okay? So we were taking this proportion, right? We said something times this 3 is going to give us this 9. And that same thing should multiply to 5 to get us this 15. It just happened to be 3. 3 times 3 is 9, and 3 times 5 is 15.
So you're just trying to get to 15.
Yeah. Like what times 5 is 15? Right? And we could have gone that way too. We could have started with these sides and said, what times 5 is 15? 15x is, right? Or we could do two different solutions, right? Where we say, instead of plugging it in like this, we could have said 15y, right, sorry, 5y is equal to 15, solved it, right, and I get y is equal to 3. So now I know that x and y are the same, so I know that their ratios are the same. So that's another way we could have solved it. A little better? It's all about ratios. It's all about getting the sides to the side that you're talking about. Good questions. Any other? Oh, that's something we could talk about later.